A very good morning, my dear students. My name is Rekha Aryan. I'll be handling physics, and you're all in 10th standard, and you also know how important this academic year, right? So you need to give your best, study hard, try to understand each and every concept rather than by-hearting or memorizing. So you need to learn the concept, just try to understand so that it will be helpful for your further studies. Whatever you will study, if you're basics are strong, then it is easy for you to understand the concept. So a heartily welcome for you all. So today we'll start our first chapter in the physics. So student science textbook contains two parts, part 1 and part 2. In each textbook we have 8 plus 8 chapters. So total how many chapters do we have in science? So total 16 chapters are there, and you already know that these chapters comes under the 3 branches, that is biology, chemistry and physics. Now I'll be taking physics, right? So in the physics we are going to see 2 plus 3 chapters, that is part 1 textbook contain 2 chapters which are highly important, that is nothing but electricity, and another one is magnetic effect. Now these two contains more weightage, and one more chapter from the part 2 for your examination. So part 1 covers electricity and magnetic effect, and in the part 2 we have 3 physics chapters, and they are light chapter, and another one is the human eye. Now in your previous class you already studied the human here, right? So here it is nothing but the continuation of light chapter. So here we'll be studying the human eye, and the third one is sources of energy. So here just look how many chapters do we have? 1, 2, 3, 4, 5. So there are mainly 5 chapters. Now listen, electricity, magnetic effect and light chapter. So these 3 have huge weightage from the physics part, and also we can include this, the human eye and the sources of energy. Along with these 5 chapters, I may also take the last chapter from the part 2 textbook, that is natural resources. So this is also you already studied. So this is nothing but a continuation of your 9th natural resources, but this comes under biology. So later we'll see this one. First I'll be covering all these 5 chapters. Okay, now just look at the chapter's name: electricity, magnetic effect and light. In the bridge course which we are giving to the class, you already studied almost all the important terms which you need to cover from this chapter. So just you need to go through once again those basic bridge course revision worksheet. Clear? So now I'll be starting electricity chapter. Now this is from the chapter 1 book, that is chapter 12 is nothing but electricity. Now you are already started to learn this from your class 6th, 6th, 7th, 8th, 9th. You already know all the basic concepts, just it is nothing but continuation of those concepts. Now just to recall, in today's life, is it possible to live without electricity? No, not at all. So in this recent times, for each and everything, from the lighting our homes, charging our devices, and for any other works, everywhere, hospitals, etc., everywhere, electricity has been an integral part of our day-to-day life, isn't it? So it has a huge application. So it became necessary to understand its origin, characteristics and utilization of electricity. So in this complete chapter, we'll be covering what is electric current and what is circuit diagram, electric potential and potential different, all circuit diagrams, and main thing we have Ohm's law and something called as resistance and resistor and heating effect. So many topics we'll be covering in this chapter. But listen, this chapter also covers numerical problems. So in the physics mainly we'll be having numerical problems from this electricity chapter and as well as light chapter. Now to solve the numerical problems, you should thoroughly prepare with your maths basics, right? So that means, see here, you need to know how to divide, how to multiply, how to subtract and addition, which you already know. Just you need to understand it more accurately, you need to know exactly what you are doing. For that, you should, everyone, each and everyone should prepare with your tables. So everyone know tables, and you need to know how to take LCM and dividing the rational numbers, and you should know that what is decimals, how to subtract, or how to multiply the numbers which contain decimal. So if you're not thorough with these simple concepts, then you're gonna make a big mistake, so you won't get a proper answer. So you need to prepare all these things. Only we have major LCM, other than that only that is nothing but multiplication and division, that's it. Okay, and one more thing we have, that is nothing but significant notation. I hope you already studied this one. If not, when I'll get this concept in the problem, numerical problems, I'll just give an introduction what is significant notation, because it is very much useful to get our answer in a very short number. Okay, so as we already know the introduction of electricity and how important it is, right? So electricity, what is the meaning of electricity, which you already know, and you already know the meaning of electric current also. When they give the term electricity, you need to define it in a different manner, and when they give electric current, you need to write a different statement, but actually both sounds the same meaning. That's it. Now listen, electricity is nothing but the flow of charges through cross section of a conductor. So you already know what is conductor and insulator. Conductor is nothing but it's a material which allows the flow of charges, right? So here electricity is nothing but in any conductor, the charges will flow through it. That's it. So it is called as electricity. Now electricity is mainly classified into two types. Now what is that? It is nothing but static electricity and dynamic electricity. Hope you already studied this also. Now what is static electricity and dynamic electricity? Now static electricity is nothing but study of these charges at rest. Now what is dynamic? Study of these charges at motion. That's it. Now you know what is rest and motion. Now rest is nothing but they should settle in some particular point. That means the charges should be at stationary, right? And what is motion? Motion is nothing but a moving particle. So if the charges are rest, then it is called as static, and if it is in a motion, then it is called as dynamic electricity. Now here we need to know the example for static electricity. Now just imagine rubbing a balloon on your hair. Now what happens when you keep rubbing a balloon on your hair? Those air started to stand towards the balloon. At the same time, you can also imagine combing a hair. Start combing your hair. Some of the airs will started to started maintain towards the comb only, no? Or else you can also imagine take your hand towards the TV. So your hairs on your hand will start standing towards the TV, right? That means when TV isn't running. So what's happening here? So there is one phenomenon is taking place in this particular static electricity. What is that? Can anyone recall? Pause and recall. It is nothing but friction. So here friction is taking place. Now what is friction? This is also you already studied. Friction is nothing but it is a type of force. Now which type of force is this? Friction is a force that holds back the movement of sliding object. So whatever we'll study in the static electricity, there the friction is taking place. So you need to remember the definition of friction also. Okay. Now can you give any example for dynamic electricity? It is nothing but look here, it is nothing but what? Motion, no? So you can easily tell now. What is that? The charge in a bulb. So the charges will be moving in a bulb when? Switch on and switch off. They'll be moving now. So study of charges when they are in moving, it is nothing but dynamic electricity. Now you understood what is electricity and two types of electricity, that is nothing but static and dynamic, along with the examples. Clear? And also you need to know what is friction, and the precise definition I have given in the bridge course worksheet. Just try to recall the same thing. And now everyone, the common thing what we observed in all the three terms is nothing but charges. That means you should already know the meaning of charges. Do you know the meaning of charge? Now can you tell me anything? And we can call this charge as electric charge. This will be calling as electric charge. Now anyone know the definition of electric charge? This is also you studied in your previous classes. Just recall. So electric charge is nothing but an electric force. Now what type of force is this? An internal property of any particle exerts an electric force towards on another particle is called as charge. Now we already know that charge are classified into two types. What are the two different types of charges? That is nothing but positive charge and negative charge, right? Now here, just to recall some of the terms from your chemistry part. So positively charged particles are called as what? Protons, no? And negatively charged particles are called as electrons. Now electrons can be written as E dash. So whenever I'll write further electrons, I'll be just writing this symbol. So you need to remember this one, okay? Now at the same time, you also studied that Rutherford model and all about electrons, and J.J. Thomson model about this electrons and protons, right? So you need to know that positive charge, these are carried by protons in an atom, right? And these are negative charge carried in an atom in the form of electrons. So if they ask what is what is positively charged particles and what is negatively charged particles, what you need to write? The definition is nothing but the electric charge carried by a protons of an atom is called as positive. Simultaneously, if it is carried by electrons, then it is called as negatively charged particles. Now after knowing these two types, we need to know that properties of electric charge. Now can anyone recall the properties? Now it's almost similar to the magnets. Everyone know that magnet has two poles, right? North and south. You know how they will attract and how they repel, right? So here also positive and negative, right? So here like charges repel. What is that? Positive and positive, negative and negative. That means they will repel. They do not attract each other. So this is a first property of charges. Like charges will repel to one another. Now unlike charges, what is that? Positive and negative will attract each other, and at the same time negative and positive. So unlike charges attract each other, like charges repel each other. So we finished property 1 and property 2. And there is a third property, that is nothing but electric charge is conserved. That means it will remain constant. It do not change in any isolated system. So what is the meaning of third property? Electric charge are conserved in a system. Now this electric charge is denoted by Q. It may be small letter q or capital letter Q. Clear? So electric charge will be denoted by Q with the SI unit coulomb, and you already know coulomb is denoted by capital C. So here you should not use small letter c, try to write a big C, okay? So SI unit of charge is what? Coulomb. These are a 1 mark question which you need to remember, especially SI units, okay? Now each charge contain one smallest value. That means each and every Q, a smallest value of any charge will be given with one constant number. The number is nothing but 1.6 into 10 to the power minus 19 coulomb. You will get 1 mark question. What is the question? Give the constant value, that is smallest value of an any charge. That is what? That is nothing but 1.6 into 10 to the power minus 19 coulomb. Now here charge contain one formula, that is nothing but Q is equal to, as I told, either you can write Q or small letter q, okay? Q is equal to N into E. Now this is a formula which you need to remember. Based on this, we'll get 2 marks question, which is also there in your in-text question. So this is important. So just try to concentrate more. Now what is this Q? Everyone know Q is what? Q is nothing but a charge. Now what is this N? So here N is number of electrons. Now what is this E? Now E is nothing but this constant value. Now what is E? E is the value of charge on an electron. So Q is equal to N into E. And you know what is N? Number of electrons. You know E. It is nothing but this constant value. Now suppose if I have 1 electron, then what will be the value of 1 electron? 1 is number of electrons, right? 1 into this constant value. Suppose if I have 2 electrons, so what will be value of the charge? If it contains 2 electrons, 2 into this value. So we should keep on multiplying number of electrons to this particular constant value to get a proper value of any charge. Clear? So this is the basic concept. Now using this one, as I told, we have one important concept. Let us see what is that. Now look at the question. Show that 1 coulomb has 6.25 into 10 to the power plus 18 electrons. That means we need to prove it. Now just write down the charge formula. Q is equal to N into E, right? Now Q means what? SI unit of Q is nothing but coulomb. So suppose if you don't have any numbers, what we need to assume? Everywhere we have only one, right? So we can write this Q as 1 coulomb. Correct, no? Now what is this N? N is number of electrons. So this is electrons. That means we need to prove that N should become equal to this value. So that is what we need to prove here. So keep N as it is. Now what is this E? E is the value of the charge, right? A smallest value of any charge is E. Now earlier only we studied what is that? The constant value. 1.6 into 10 to the power minus 19 coulomb. Everyone wrote now this particular point. You need to understand how we are getting this one from this formula. Correct. Now what we need to find out? N is equal to 6.25 into 10 to the power plus 18. So I can simplify this equation as 1 divided by 1.6 into 10 to the power minus 19 is equal to N, right? Just a cross multiplication, a very simple step. Now we have N, so you need to calculate this particular part. Now what you need to do? Divide 1 by 1.6. So how much you will get? You will get 0.625. Now listen, you are not supposed to use calculator, right? That means each and every worksheet you need to do. So just put one line next to your examination sheet whenever you are writing. So just put as worksheet and work it out. Whatever you want to write, work it out. And that particular answer you need to write here. Okay. And here we'll get 0.625. How? By dividing 1 with 1.6. Now just look at the denominator. What we have here? 10 to the power minus 19. Now whenever the exponent transfer from denominator to numerator, the sign will change simultaneously from numerator to denominator. That means if it is 19 in the denominator, when it comes to numerator, what happens? It will convert into positive, which you already know. So this minus 19 will become into what? It will become into 10 to the power plus 19. So this is just the answer. It is enough, no? But look at the given question. Here they are mentioning plus 18. That means I need to change this number so that I should get it as 10 to the power plus 18. Earlier I just mentioned one term called as scientific notation. That is nothing but this one. We need to, the meaning is same, the value is same, just we'll be writing in the different form. So here what happens? So here if I take this decimal to this particular point, what I will get? 6.25, and this will decrease. That is nothing but 10 to the power 18. So, and unit is must and should, that is nothing but electrons. Now what we proved? 1 coulomb has 6.25 into 10 to the power plus 18 electrons, and this is your answer. Now this is very important because this question is there in your in-text part. So here whatever the question will get from the in-text as well as exercise at the same time example are very important from the examination point of view. Now just pause the video and recall what and all you studied. So everything we studied under the charge. So first we studied what is electricity. Then electricity we studied two types. What is that? Dynamic and static. In that we heard a word called as charge, so that we studied the properties of charge. Now we are going to our main concept, that is what? Electric current. So what is electric current? The definition is nothing but rate of flow of electric charge. Now can you recall what you just learned about the definition of electricity? Electricity is nothing but the flow of charge through cross section of a conductor. Now look here, rate of flow of electric charge. Both the definition gives same meaning, no? Just while writing you need to differentiate, that's it. Understood? So while writing you need to differentiate it properly. Now electric current is nothing but rate of flow of electric charge. Now here, can you tell me or can you recall what is the symbol which you are using to indicate the current? That is nothing but I, no? So I is a symbol which will be indicating the electric current. Now can you tell me the SI unit of this one? SI unit of electric current is nothing but ampere, which is denoted by capital A. So remember, SI unit of both charge as well as ampere are important, and it is also important what and all we'll study further, like Ohm's law, resistance, and many more we have, potential difference, etc. So next, these comes under the properties of electric current. So we are starting properties, which is denoted by capital I, with the SI unit ampere, which is denoted by capital A. Now charge, this one, what is this? Current. Current has a formula. So current is denoted by what? I. So I means you need to understand it is current. I is equal to charge divided by time. Now how we'll be writing this formula? Formulas will be always constructed based on the definition. Rate is nothing but which indicates the time. So listen here, electric current is nothing but flow of electric charge with respect to some time. So the formula should be charge divided by time. Now this is what? Current. So this is the formula. Now let me write again one more formula. I is equal to charge is denoted by what? Q, no? Now time is denoted by what? T. This is also formula. Now I will write the same formula in terms of SI units. Now what is the SI unit of I? That is nothing but ampere. What is the SI unit of charge? That is nothing but coulomb. What is the SI unit of time? That is nothing but seconds. Now listen here, we wrote 3 formulas. These both are same only. So it is nothing but in the name of names, it is with the symbols and it is with SI units. Now you will get a question, define current or define 1 ampere. As I already mentioned, if you don't have any coefficient here, it is nothing but 1 only, no? So here you will get a question, what is define 1 ampere or define an ampere. So what is ampere? Ampere is nothing but coulomb per second. Correct, right? Or we can also write this as coulomb per second. The same statement, the same thing you need to make into statement. That's it. Just you need to analyze the concept so that you will get a proper answer. Now the next thing is current can also, as we already know, current, how we'll get? We'll get one number, no? I have 5 ampere, I have 10 ampere, that's it. So in an electric circuit, we need to define it with some number. Here, current will expressed in another 2 forms called as milliampere and microampere. So this is very important, you need to remember. Now current can expressed in 2 different forms, that is when we are taking numerical number, that is milliampere and microampere. Now listen here, milli, I'll write the same thing here. 1 milliampere is indicated by what? Capital A, no? A. Now look here, 1 micro. Milli is denoted by small letter m, micro is denoted by with this symbol, which is this also will be used for another some other terms. Just now make sure to remember, micro will also be used with this Greek letter which is called as mu, mu, but we'll pronounce it as mu, or someone will tell it as mu. So anything is fine, mu or mu, actual name is mu. Okay, so ampere. So this is the name, this is the symbol, and value of milli, everyone know the value of milli is what? 10 to the power minus 3 ampere. Now what is 1 microampere? Micro will always stand for 10 to the power 6 ampere. Okay, now these are some of the terms which you should not forget, because you'll be keep on using. So similar thing, you need to recall that 10 to the power 3 plus 3, which is denoted by kilo. And what is the value of centimeter? Cm. C is nothing but 10 to the power minus 2. and micro here we have, and nano, which you'll be using further in your PU and all. Nano is nothing but 10 to the power minus 9. So these are the some values. Right now you need to remember this micro and milli. Clear? So also under the properties of electric current, we have one more important point. Everyone know that how electric circuit looks now, which you already studied, but still we have the same thing in this syllabus also. So I'll be dealing that one next after some few moments. So before that, we need to understand one statement, that conventionally. Now what is this conventionally? So after conducting a number of experiments, we'll be concluding with some particular statement, and that is nothing but here in an electric circuit. So suppose if this is an electric circuit, so mainly what we have, we'll get a battery, key and ampere, etc. So here in an electric circuit, the current, the direction of electric current, that means what? I. The direction of electric current is opposite to the direction of flow of electrons. So let me repeat the same statement. Direction of electric current will be opposite to the direction of flow of electrons. Important statement. Either you will get in the form of MCQ question or with a 1 mark question. So always you need to remember that the flow of current will be always opposite to the flow of electrons. Clear? At the same time, vice versa, the flow of electrons will be opposite to the flow of current, which one we are assuming conventionally. So this one again I'll confirm when I start with this electric diagrams, which we'll be studying all the next topics based on the circuit diagrams. Clear? Now these are the basic things which you need to remember. And we got one formula now. So here also we'll get one numerical problem, a very simple question. Just they will give two values, just we need to find out any particular one. So I'll give one problem now. Clear now? So here we'll solve one example problem. A current of 0.5 ampere is drawn by the filament of electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. Now listen, whenever you are solving a physics problem, soon after reading the question, you should write the given terms. So given, just see what is that? Current. Current is denoted by what? I. I is equal to what? 0.5 ampere. Now what they are given? Drawn by a filament of electric bulb for 10 minutes. Minutes means what? It is time, no? So time is 10 minutes. Now what is the SI unit of minutes? Time? Seconds. Now just look at here. We have in the minutes. That means we need to convert this into seconds. Clear? Now how to do that one? So it is nothing but 10 into 60. 10 minutes. Each minute contains 60 seconds, right? So how much we'll get? 600 seconds. That's it. Now next what we have? Find the amount of electric charge that flows through the circuit. Find the amount of electric charge. We need to find out Q. Right. Now what is the formula? I is equal to Q by T. What is Q? That is what we need to find out. So here what you need to do? A simple cross multiplication. So what is that? Q is equal to I into T. So this is our main formula. Now listen, you need to write the relevant formula first, then modification of that formula based on the problem. Formulas contain marks. And I is what? I is 0.5 and T is what? Time in a seconds, that is 600 seconds, and multiply these two, how much will get? 300. Now how to write SI unit? This is what? Q, no? Q, charge. What is the SI unit of charge? That is coulombs. So this is your answer.